SpaceX continued its relentless launch pace into May, successfully deploying another batch of Starlink satellites on the evening of May 1, 2025. The Starlink 6-75 mission lifted off from Space Launch Complex 40 at Cape Canaveral Space Force, stationed in Florida aboard a Falcon 9 rocket at 9:51 p.m. EDT. This flight delivered 28 Starlink V2 mini satellites to low Earth orbit, further expanding the company's internet constellation, which now numbers over 7,300 operational units. The mission utilized the Falcon 9 first stage booster designated B1080, completing its 18th successful flight. This particular booster has a notable history, having previously supported 2 private astronaut missions to the ISS, 2 cargo resupply missions, the launch of ESA's Euclid Space Telescope, and numerous other Starlink deployments. Following stage separation roughly 2.5 minutes after liftoff, the booster executed a successful landing on the drone ship Just Read the Instructions, stationed in the Atlantic Ocean, marking the 440th overall booster landing for SpaceX. This launch was SpaceX's 51st Falcon 9 mission of 2025, maintaining a high cadence necessary to approach its ambitious yearly launch targets. Next news, astronomers have identified a second enormous structure in the distant universe, further challenging the standard cosmological model and the principle of large-scale uniformity. Named the Big Ring, this structure appears as an almost perfect ring of galaxies and galaxy clusters, located approximately 9.2 billion light-years from Earth. It boasts a diameter of about 1.3 billion light-years, making its scale comparable to the previously discovered giant arc, which resides in the same region of the sky and at the same cosmic distance. The existence of such ultra-large structures exceeds the theoretical size limit predicted by current cosmological models, around 1.2 billion light-years. Detailed analysis suggests the Big Ring might actually be a vast coil or corkscrew-shaped structure viewed face-on from Earth. While it could potentially be related to baryon acoustic oscillations, BAOs, frozen remnants of sound waves from the early universe, its specific shape and precise size don't perfectly align with typical biocharacteristics. Alternative explanations such as conformal cyclic cosmology or effects of cosmic strings are being considered, but the true nature and origin of the Big Ring and giant arc remain profound mysteries in cosmology. Next news, Corsair has released a set of 3D printable files enabling PC enthusiasts to construct an open-frame computer case designed for mounting components directly onto a pegboard system. Inspired by wall-mounted PCs, this approach allows builders to showcase their hardware components openly, promoting better airflow and potentially saving desk space. While specifically designed to integrate with Corsair's own platform and Platform 6 desks featuring pegboards, the files are released under a Creative Commons license, CC 4.0 Attribution Share Alike, potentially allowing for adaptation to other standard pegboard systems like the popular Scotus. The design supports both ATX and ITX motherboard form factors, with pre-sectioned files for smaller printers needing the ATX mount, and accommodates various power supply unit sizes including ATX, SFX, and Corsair's Shift models. Mounts are provided for substantial dual and triple slot graphics cards, as well as for 120mm, 240mm, and 360mm radiators or standalone fans. Corsair indicates that standard PLA filament has proven durable enough for the mounts in testing, likely due to the ample airflow inherent in the open-frame design, mitigating issues like heat-induced sagging. Next news, following its successful launch on March 11th, and a 6-week period of in-orbit checkouts and calibrations, NASA's SPHEREx space telescope has officially commenced its science operations as of May 1, 2025. SPHEREx, spectrophotometer for the history of the universe, epoch of Ryanization, and ICE's Explorer, is now actively mapping the entire celestial sphere. The observatory captures approximately 3,600 images daily, using 6 detectors sensitive to 102 distinct wavelengths of infrared light, invisible to the human eye. By employing spectroscopy, which separates light into its component wavelengths like a prism. SPHEREx can gather detailed information about cosmic objects, including their composition and distance. Over its planned 25-month primary mission, the spacecraft will orbit Earth roughly 14.5 times per day in a polar orbit, methodically scanning strips of the sky. This process will allow it to survey the entire sky 4 times, generating comprehensive all-sky maps. Key science goals include creating a 3D map of hundreds of millions of galaxies to probe the physics of cosmic inflation in the universe's first moments, measuring the collective glow of all galaxies throughout cosmic history, and identifying water ice and organic molecules, key ingredients for life, within the Milky Way, shedding light on the origins of life's ingredients. Next, news researchers from the University of Miami, in collaboration with Georgia Tech and the University of Rochester, have developed and characterized a novel organic molecule exhibiting exceptionally high electrical conductance, potentially paving the way for smaller and more efficient electronic devices. Published in the Journal of the American Chemical Society, their findings demonstrate that this molecule, primarily composed of carbon, sulfur, and nitrogen, can transport electrons over distances exceeding 20 nanometers with negligible energy loss. This near-perfect length-independent conductance under low bias conditions approaches the theoretical conductance quantum, 1G0, and overcomes the typical exponential decay observed in most molecular wires. The molecule employs an open-shell donor-acceptor structure that facilitates resonant charge transport, essentially creating an unimpeded pathway for electrons. This breakthrough in molecular electronics addresses a key challenge in miniaturizing components beyond the physical limits of silicon-based technology. Beyond enabling smaller classical computing elements like wires and transistors, the researchers suggest the molecule's unique properties, stemming from interactions of electron spins, could also open avenues for developing molecule-based quantum information science applications, potentially serving as a qubit. The molecule is reported to be chemically robust and air-stable, enhancing its potential for practical integration. Next news, the burgeoning number of satellites in orbit, particularly from large mega-constellations like SpaceX's Starlink, is raising significant concerns about atmospheric pollution caused when these objects burn up during re-entry. As satellites predominantly constructed from aluminum disintegrate upon entering the atmosphere at high speeds, they release aluminum oxide, Al-2O3 particles into the stratosphere. Recent measurements indicate that around 10% of SPHEREx aerosol particles now contain metals originating from space debris re-entry. Scientists are worried because these alumina particles can persist at high altitudes for decades or longer, and are known catalysts for ozone depletion, potentially undermining the recovery of the Earth's protective ozone layer achieved through efforts like the Montreal Protocol. Furthermore, the accumulation of these particles could alter the atmosphere's albedo, reflectivity, and radiative balance, impacting climate. While the space industry's current contribution to overall ozone damage is relatively small, the projected massive increase in satellite launches and subsequent re-entries means this pollution source is rapidly growing, posing a long-term environmental challenge that requires further research and mitigation strategies. Rocket launches themselves also contribute pollutants like black carbon and chlorine directly into sensitive atmospheric layers. Next news, NASA is maintaining efforts to re-establish communication with its Lunar Trailblazer spacecraft, which fell silent on February 27th, just a day after its launch alongside Intuitive Machines' Athena lander. Initial assessments indicated the 200-kilogram probe, designed to map water ice on the Moon, entered a slow spin and was unable to generate sufficient power from its solar panels. Despite the challenging situation and over 2 months without contact, the mission team is continuing recovery attempts. Mission modeling suggests that optimal lighting conditions occurring from May through mid-June 2025 present the best window for the spacecraft's solar panels to potentially receive enough sunlight to recharge the batteries to an operational level. If communication and command capability can be restored during this period, And if the propulsion system can be thawed and instruments are functional, NASA believes it might still be possible to maneuver Lunar Trailblazer into an elliptical lunar orbit and achieve its scientific objectives. The probe's precise location is known via ground tracking. A continuation termination review will be held if contact is made. Otherwise, if no signal is received by the end of the mid-June window, NASA will initiate mission closeout procedures.